This is a piecewise function where we're being asked the limit as x approaches 1. I want to show you two ways to do this problem, one of which is graphically. So we want to get a good sense of what this piecewise function looks like. What we're going to do is we're going to start by graphing 3x minus 1, which is a line with a slope of 3 and a y-intercept of negative 1. Bear in mind this function only exists for values of x that are not equal to 1, so there's going to be an open circle somewhere on this graph, and namely at x equals 1. So this is a line with a y-intercept of negative 1 and a slope of 3. So it's going to be, let's plot some points actually. When I plug in 0 to this function, I get negative 1. When I plug in 2, I get 2 times 3 is 6 minus 1 is 5. It's going to be way up here. And then when I plug in 1, I get 2. But now bear in mind, this says x is not equal to 1. Sure, I understand that we're not allowed to plug in 1, but we want to see what hole or what circle would have been filled in had we plotted the value at x equals 1. So when I plug in 1, like I said, I got 1 times 3 is 3, minus 1 is 2. I'm going to put an open circle there to indicate that, yeah, well, this will be a line that goes connecting these points. I should have done it a little bit higher. It's fine. There's still going to be an open circle there at x equals 1. Now, the rest of this function, piecewise defined, is it has the value of 1 at x equals 1. That means the y value is 1 at x equals 1. So I'm going to put a closed circle here. So graphically speaking, we've kind of drawn what this piecewise function looks like, and now we just need to evaluate the limit as x approaches 1 of this guy. Bear in mind that this is a two-sided limit, so we need to check both the left and the right-hand side. As I draw my pen, or put my pencil on the graph and draw from the left, I approach the y value of 2 when I approach the x value of 1. Similarly, when I put my pencil on the graph here and draw from the right, by approaching the x value of negative 1, I approach the y value of 2. So this limit, graphically speaking, is 2. But I want to show you a different way if you do want to draw the graph. For this problem, you can simply take the x value that we're being approached and plug it in to this part of the function. Now that might seem confusing because after all, it does say x is not equal to 1, but that's the point, right? A limit isn't the value of a function at the point. It's the limit. The limit is the value as we get closer to that point. So even though the value of the function is 1 at 1, that's not the limit. The limit is the value we get as we approach 1. And so what we're going to do is we're going to plug 1 into this function, not to this function. So when we plug in 1 to 3x minus 1, 3 times 1 is 3, minus 1 is 2. And that was obviously a lot faster than drawing the graph, but I wanted to show you both ways so you know how to get an answer.